Okay, so what I want to do now is sort of layer another one sort of next to it. So I'm just going to move this guy a little bit out of the way, so something maybe like over there. And let's copy this, paste it, and let's change some values just so we can start to offset this sort of over there, maybe over there. And let's add some more into this guy, so something like, yeah, 20. That's quite heavy, but let's make it a bit bigger, 1.5 and maybe 1.5 as well. A bit too big. That's quite cool. Alright, let's go with that one, but maybe 16 just, or 14 for starters. We can always sort of, change this afterwards if we need more detail. We can also rotate it if we needed to, but don't know. Yeah, looks quite good to me. Okay, let's use this. So the next step, the problem is that there are like these ultra small pieces, like where they like these super small triangles, and I don't really want those in my calculations later on. So what I'm going to do is kind of fuse them together, so I don't need to bother with those really small pieces anymore. So let's have a look until it sort of disables itself. So there we go, we're starting to get rid of some of those. So something like 0.9 already kind of does the job. You can kind of see over there we don't have those super small pieces anymore. It kind of really depends how small you want your simulation to go, but I think something like this, I don't know, should do. Yeah, that'll do fine. And let's get rid of the grid as well. Okay, so this, what I want to do now is break it up into different sort of pieces. The way I'm going to do that is by assigning a different color to every single primitive. Now let's just have a quick look to our primitives. And as you can see over there, I've got 153 primitives. So this will become important, the number of primitives that you have for your sort of precision of assigning values. So let's add a primitive, sop, as such. And I'm going to add some color to it. Attributes, add color, right? What I'm going to do there is just add a ratio to this. So let's say the current primitive number, divided by the maximum primitive number. So NPR. And let's copy this for all the channels so that it's black and white, so grayscale value as such. So we're getting this grayscale value now, and it's assigned to every individual primitive. So if I just bring up a spreadsheet, then you'll notice, if I just turn this to primitives, then you'll notice that the values are in floating point, which basically returns, a very detailed number. Now when we start to partition this next, in the next operation, we will start to lose some of this detail unless we take this into account. So what I mean by this is that if I add a partition to this, right, we can use the rule, and the rule will be color, so group by color. But the problem is this expression, this rint, this will basically round the integer, to become an integer. So what I mean by that is it will chop off bits of the value. So in this case, the CR, which is a floating point value, so something between 0 and 1. So this could be, let's say, 0.567, something like that, times 255. This will boost up that number, and as a result, we will get all these groups, as you can see, which have nice integer endings. The problem is, if your primitives, the amount of primitives is higher than 255, then your colors will start to round and you will have a primitive there and a primitive there. So I'm just gonna show you quickly what that could be like. So if I just say, maybe I'll just boost this number to something like 16 temporary. Let's hope this goes over it. Yeah, this will do. I've got 259 primitives. That means that there are actually some primitives that sort of say that this guy is gray and this guy is gray, and let's assume that they have the same sort of, they will have the same value potentially when they are rounded, when this rounding operation goes through. So in order to sort of get rid of that, we can just multiply this by 10, which will increase the accuracy by 10. So you can say there, that guy by 10, that guy by 10. And the last one, so if I bring up my expressions, so this guy by 10, this guy by 10, and this guy by 10, multiply it by 10. Okay, and just say apply. So now we can go up to sort of as high as 2,500 different pieces. Now you're gonna have to watch out a little bit with your amount of pieces. I mean, don't go crazy on your subdivisions, because obviously you might run out of memory, and you know, don't want to do that. But as you can see now, the groups over there, right, they are different in the sense that they have more detail inside of them. So, well, basically these extra 4 primitives above 255 will sort of be able to handle that. Okay, so then what we can do now is, instead of partitioning it straight away, we're gonna sort of break up these pieces a little bit more chaotically. So in order to do that, what I'm going to do is I'm going to triangulate this geometry, the geometry that comes from my fuse, so that doesn't even have the color information on it. So I'm just gonna triangulate this, right? And what I'm going to turn on is refine, which will allow me basically to change my area settings so that I can have a nice sort of equal, you know, a nice sort of equal split. And this is really, you know, this is a details control really. So something like 0.05, you know, so we got a nice sort of spread. And notice that the areas where, you know, there was a lot of splitting in the past, so there's my center, there's another center, those are a bit more detailed. I mean, it's really up to you how much detail you want. You can go really crazy on this, but okay. Then what I want to do as well is a try divide. So this will divide it again. If I change my depth to 1 and make it sort of really sort of smooth, so my pieces will, you know, have a lot of detail to them. Next step is to transfer my colors that I assigned over there, to transfer that to my triangulated geometry. So in order to do that, I'm going to do an attribute transfer as such, and this will be from this geometry onto this geometry. So let's see. So automatically, since, you know, the source group and the primitives are, you know, already been set, all the attributes are automatically transferred, the primitives. So the color, I can just transfer the color, and you know, that'll do what I needed to do. So as you can see now, they've all sort of been assigned their own individual colors. If I needed more detail at this point, I could just go back up and just say change this to 0.4, and note that this will change, you know, as soon as I enter, you know, to a more detailed version, something like 0.1, and it is going to become really high detailed. Yeah. Alright, but we don't need to go that high for our purpose. And now what I'm going to do is use that inside of my partition. Yeah. And as you can see, I've got just all my groups, all my individual groups, and that's what I mean over there. Say, you know, this group, for instance, 2068, instead of being 206, it now has the 8 to differentiate between it, right? So there's a whole bunch more primitives now. Yeah. Okay. At this point, I'm going to start breaking up my geometry, because at this point it's still all, you know, individual pieces. So the way that I'm going to do that is I'm going to add a null to this, and let's say null sort of before split. Yeah. Okay, I'm going to add a for each, and I'm going to start using my expressions. What I want to do is I want to use every individual group and sort of delete everything else. So I'm going to sort of loop through my groups, right, and select the current group and delete everything else. So inside of my for each, I'm just going to add a delete to this. Well, actually, I'm not going to use my geometry. I'm just going to use that, you know, for looping purposes. So now you will see where the merge will come in handy, right? So I'm going to delete basically any of these groups. I need to make sure this sort of input's in my second input. It doesn't need to be input in my first necessarily. That'll just be, you know, enabling the each to, you know, to activate sort of the looping. So what I'm going to do is I can choose any of my groups. So say if I choose color 00 in there. Oh. Something like that. Oops, was I on my... No? Let's have a look. Okay, so anyway, there's my group as such. And what I want to do is I want to delete non-selected. Yeah? So I'm just going to delete everything else. Make sure that instead of each group it says each number. Yeah? Maybe I should have done this first. Better to do this first. Okay. What I want to do as well is this output will need to be merged, so you definitely want to merge the results. At the moment it's going to loop 10 times, but it's only going to delete this one group, or rather it's only going to keep that one group. So what I want to do really is going to start cycling through those groups. And which groups? Well, it'll be the groups that come from my null before split. So the way that I'm going to do that is it's gonna start, since my group sort of will be my groups will I'll start looping through them rather using an expression. So the expression I'll be using is prim group mask. So prim group mask, and I want to start using it from the null before split. So this will be the sub I'm gonna start sort of getting my primitive groups from. The ones that I need will be, so there's my null. I want everything that basically starts with color. So color star. Okay, so at the moment this will return me a string with all my groups in it, right? That's not what I want, so I'm gonna put my arg expression in front of it, rather my argc, to count my arguments, because I'm putting it into my number range. So this is how much times do I need to loop through. Well, I need to loop through the amount of times that I've got pieces. And let's just copy this because we'll be using it inside soon as well. Okay, just apply, accept. Okay, so I've got 259 groups, just like I had 259 sort of pieces over there, these primitives. Okay, let's go inside and let's delete in the same way. We're just going to get rid of that, and let's bring in our expression editor, paste that expression. Instead of using this prim group mask, what I'm going to do now is just use the arg expression. This will sort of cycle through the arguments, will allow me to cycle through the arguments. So if I say I'll start at argument 0 as such, and I apply this, accept this. One more thing I need to do is put in little backticks in the front and on the end, so that it will evaluate first. And let's have a look. Okay, so it'll loop through 259 times, and it'll delete sort of all these groups. The other thing that I forgot to do is just the path for my null at the moment is not correct. It needs to go one step higher because I'm inside of my for each loop. So let's add another sort of step up to this, and let's apply it now, accept this, and there's my little piece of geometry again. Now the nice thing is, again, you can just change this number, and it's gonna start looping through my different pieces. So that's quite convenient. Now I'm gonna put my stamp from my each in there, so this stamping that I've just got over there, so my stamp, get it from your each, and just copy this, go back to your delete, bring up your expression editor, and let's put that in as an argument, right? And make sure that it is not a string, but that it is over there, that is a value. So not stamp string, but just a stamp, right? Okay, when that's done, just apply and accept, and let's move up. Now it's probably going to give me one little error problem because it starts, or rather, see, there's a piece missing, because it starts at 0, right? Sorry, it starts at 1 and it should start at 0. So let's make it start at 0, and let's make this argument primitive list one smaller, -1, as such. And now it loops through all the groups correctly. All the groups should be in there. Okay. So now that I've got all my separated groups, I can sort of continue on with this broken up pattern and take it into dots or take it into expressions or particles, sort of depending, procedural modeling if I wanted to. So in the next example I'm going to take this into a sort of breaking up cloth example. It's going to be very short.